Hello learners, in this lecture we will study determinants and property of determinants. Definition. In terms, determinants can be defined as a numerical value obtained from a square matrix of the coefficient and certain unknown variables enclosed by 2 bar of the process of diagonal expansion to let upon a given algebraic system. Let a11x plus a12y is equal to 0, a21x plus a22y is equal to 0. By eliminating x and y, we get the expression as a11 a22 minus a21 a12 is equal to 0. Characteristics of a determinant. From the above definition, the essential characteristics of a determinant may be analyzed as under: it is a numerical value, it is obtained by a square matrix, it is obtained from the coefficients of certain unknown variables, say x, y, z, etc. It is obtained from a square matrix enclosed by 2 bar in its left and right hand sides. It has a large number of algebraic properties. Cofactor and minor. By the cofactor of an element of a determinant, we mean the product of this equation and the minor of the concerned element. Symbolically, it is given by this equation where Cij, the cofactor of the element in the ith row and jth column of the determinant. Now, minor. By the minor of an element of a determinant, we mean the subsquare determinant of the given determinant along which the particular element Aij does not exist. This is obtained by deleting the row and the column on which the particular element Aij lies. It is represented by Mij, which denotes the minor of an element in the ith row and jth column of the determinant. Its value is obtained by reducing the product of its non-leading diagonal elements from the product of its leading diagonal elements. Properties of a determinant. If any row or column of determinant consists of 0, only then the value of a determinant becomes 0. If any two rows of column of determinant are identical, then the value of the determinant becomes 0. The value determinant remains unchanged even if its rows and columns are interchanged. If any two adjacent rows or columns of a determinant are interchanged, the numerical value of the determinant remains the same but with the opposite sign. If every element in the row or column consists of the sum or difference of two quantities, then the determinant can be expressed as sum or difference of two determinants in the same order. If each determinant in a row or a column of determinant is multiplied by a constant k, then the value of the new determinant is k times the value of the original determinant. The value of the determinant remains unchanged if to each element of any particular row or column of the determinant, the equi-multiply of corresponding elements of one or more rows or columns be added rows or columns of determinant are multiplied in order by the cofactor Cij of the corresponding elements of any other row or column. Then the sum of the products thus obtained is 0. Thank you.